This is the video for section 5.2. This one is about verifying trig identities. What it means when we verify a trig identity is that we use other identities and facts that we know and algebraic processes to show that the expression on one side is always equal to the expression that's on the other side. When we look at identities, they're going to look like equations, but as this first point says, the procedure when we're verifying identities is not the same as the one that we use when we're solving equations. Things that we do solving equations, things like adding the same term to each side or multiplying each side by the same expression, shouldn't be used when we're working with identities. One of the first things we talk about in order to avoid that temptation is a strategy where we only work with one side and we just rewrite it to match what's on the other side. When we do that, we want to start out with the more complicated side of the equation and rewrite it so that it's identical to the other side, which would be the simpler side. When we're selecting different identities and substitutions to use, what we want to do is to keep in mind the simpler side, the one that we're not changing, because that represents the goal. That represents what we're trying to get to. The next four strategies are what we're mainly going to use in verifying identities. The biggest one is to learn the fundamental identities that we talked about in the last section. Know them well enough so that when you see either side of one of them, you should think of the other side of that identity. And be aware of the alternate forms of those identities, such as the ones we talked about in section 5.1. When we're trying to verify an identity, a technique we use a lot is to do any factoring or any other algebraic operations. Things like multiplying, distributing factors, simplifying rational expressions. Another strategy we use quite a bit is to rewrite all the trig functions in the identity in terms of sine and cosine, and then simplify what we have from there. Another one that we use sometimes is that if we have an expression, something like 1 plus sine of x, we try multiplying the numerator and denominator of our expression by 1 minus sine of x. What we're looking for is the two different factors that we would need for the difference of squares. If we had 1 plus sine x, the other factor we need for the difference of squares would be 1 minus sine x. This can come up in lots of different forms. This is just an example. In this video, we're going to do lots of examples of verifying identities so that you can get some idea of the type of thing that we're trying to do. And for each one of these, I'm going to write on it which one of those strategies I'm using. With this first identity, we're only going to work with one side. We want to look at the two sides and see which one looks more complicated. Definitely for this one, the left side looks more complicated. So that's the one that we're going to work with and try to simplify. So right here we're talking about strategy number 2A, that we're working with the more complicated side. And as we go, we're going to keep writing this side just so that we can keep in mind the goal that we have to get to. If we're going to simplify this side, one of the first things we could do is from strategy number 4, and that is just to do any algebraic operations that are there. In this case, we've got a multiplication, so we're going to take this and distribute it to both of these terms. That gives us secant x sine of x plus secant of x cosine of x. Now the next strategy we could use is number 5. That's the one that says to rewrite everything in terms of sine and cosine. We can rewrite secant as 1 over cosine of x. And since I'm going to end up looking at these as rational expressions, while I'm doing this, I'm going to write this as sine x over 1. The same thing here, I can write secant as 1 over cosine, and I'm rewriting this as cosine of x over 1. Now I'm going to go back to strategy number 4, which is to do algebraic operations. In this case, that means actually doing this multiplication. That's going to give me sine x over cosine x here. And here it will give me cosine of x over cosine of x. I can actually cancel those two, and I end up with just a 1. Now, as I'm doing this, I keep rewriting this tangent of x plus 1 over here because that's my goal. If I compare what I have here to what I want, I'm almost there because I can rewrite sine x over cosine x as tangent of x. Recognizing that this is tangent of x, that's strategy number 3, which says to keep in mind those fundamental identities. So I'm using that quotient identity to rewrite sine x over cosine x as tangent of x, and now I have exactly the same thing on each side. So by doing this, I've shown that this identity is true because I rewrote this side and got it to look exactly like the other side. Let's do the same thing with this one. Again, with this one, the left side is more complicated, so that's the side I'm going to work with. Again, the first thing that I can think about doing is the multiplication. That means I'm going to distribute the cotangent squared x to both of these two terms. So here I have cotangent squared x times 1, so that's just cotangent squared x. Now the next thing I could look at is some of those fundamental identities. Cotangent, remember, is 1 over tangent, so I could rewrite cotangent squared as 1 over tangent squared. That's just using one of my reciprocal identities. Now I can simplify this, so I'm back to strategy number 4 where I'm just doing algebraic operations. I have a tangent squared on the top and the bottom. Those two cancel, so I just have a 1. Another thing that isn't one of those actual strategies, but is something to keep in mind, is that anytime you have one of your trig functions squared, be thinking about those Pythagorean identities, because they all involve the trig functions squared. When I get down to here, this is actually one of those Pythagorean identities. 1 plus cotangent squared of x is equal to cosecant squared x. So this is number 3 where I'm recognizing those identities. And now I've shown that I have the same expression on both sides. Now for this example, definitely this side is the more complicated one. And even if you don't like to work with rational expressions, if you have an identity and one side has a rational expression, that's definitely the side that you should be working with. You have to go through and simplify the rational expression as much as you can. I'm going to start out by doing that. For a lot of these identities, there are several different ways that you can go. In this one, we could start out by rewriting everything in terms of sine and cosine, or we could start out with some algebraic operations. That's what I'm going to do. I'm going to just split this into 2 different rational expressions. In a way, I'm taking the denominator and distributing it to both of the terms in the numerator. One of the reasons I'm doing that, though, is if I look at my other side, this has 2 terms that are subtracted. So if I split this into 2 terms, they're subtracted, and I'm thinking that that looks more like the form of this one. Now, to keep simplifying these two, here's where I'm going to rewrite these in terms of sine and cosine. I already have sine and cosine on the bottom, but the tops, the tangent and the cotangent, those I'm going to rewrite in terms of sine and cosine. So this is using strategy number 5. Tangent of y is the same as sine y over cosine y, and cotangent of y is the same as cosine y over sine y. Now I have to simplify each of these rational expressions. Remember, if you have something like this that doesn't have a denominator, you can rewrite it in a fraction form by writing it over 1. Then with each of these, I'm going to invert and multiply. So I'm going to take this and flip it over and multiply it times this, and the same thing here. So this is really number 4 where I'm just simplifying my rational expression. That's going to give me sine y over cosine y times 1 over sine y cosine y. And with this one, it gives me cosine y over sine y times 1 over sine y cosine y. Now I'm still simplifying. I've got a sine y on the top and the bottom of this one, so I can cancel those 2 out. Then what I have left is a 1 on the top and cosine y times cosine y on the bottom, that's the same as cosine squared y. Here I can cancel the cosine of y on the top and the bottom. What I'm left with is 1 over sine y times sine y. That would be the same as sine squared y. If I look at my goal, I'm almost there. All I need now is my reciprocal identities. 1 over cosine squared y would be the same as secant squared, and 1 over sine squared y would be the same as cosecant squared y. This time, even though we had these trig functions squared, we didn't end up using any of those fundamental identities. Let's look at another one, and here we're still only trying to work with one side of our equation. This time there really isn't one side that looks more complicated than the other. I'm just going to choose to work with the left side. So I'm going to work with this side, and I'm going to try to rewrite it so that it looks just like this side. But this is one where I can use strategy number 6. Because I have a 1 minus sine x, I'm going to multiply the top and the bottom of this expression by 1 plus sine of x so that I have the difference of squares. We don't use this strategy quite as often, but it does come in handy sometimes. Another clue that I might want to use this strategy is that on this side I've got a 1 plus sine x. So I'd like to put a 1 plus sine x on the top of this so it would match this one. And by multiplying the top and the bottom of this by 1 plus sine x, I've got that there now. Now what I need to do is on the bottom, multiply this out, and this is the difference of squares factored. So if I multiply this out on the bottom, my two middle terms in FOIL would cancel, and I'd end up with 1 squared, which is 1, minus sine squared of x. Here's a place that I need to recognize an alternate form of one of those identities. 1 minus sine squared x is equal to cosine squared x. That's an alternate form of one of the Pythagorean identities. I can rewrite the bottom of that just as cosine squared x. I rewrote this over here so I had more room. The next thing I can do is just simplify this. I've got a cosine x here and a cosine squared x here, so I can cancel out a cosine x. And that leaves me with just a cosine x on the bottom. And that's exactly what I wanted to have. Now I've got the same thing that I have on the right side. Now we don't always need to just work with one side. You can work with both sides at once, especially if there's an easy way to simplify things on both sides. So for these two examples, we're going to work with both sides. But we're still not using some of the equation solving principles. We're not going to be multiplying both sides by the same quantity or adding or subtracting the same quantity from both sides. That's equation solving strategies. We're just verifying identities. So we're going to work with each side separately and try to get them to look the same. On the left side of this, I'm going to use strategy number 4, which is I'm going to do algebraic operations. I'm going to distribute the tangent squared x to both of these two terms. On the right side of this, I'm going to use a different strategy, which is recognizing one of our fundamental identities. 1 minus sine squared x is the same as cosine squared x. So here I'm actually using strategy number 3. I'm going to rewrite this as 1 over cosine squared x. Now on this side, I see one thing I can do. I can use a reciprocal identity to write cotangent squared as 1 over tangent squared. On this side, I can also use a reciprocal identity to write this as secant squared of x. Then on this side, I'm going to simplify this. I've got a tangent squared both places. I can cancel those out, and that gives me tangent squared x plus 1. Now, I've got one of my Pythagorean identities. I have tangent squared x plus 1 on this side, secant squared x on this side. So I just have to go back to that Pythagorean identity. This is equal to secant squared x. One more identity. This one, we're going to use a slightly different version of strategy number 4. If you look at both sides of this one, both of them have multiple exponents of the same trig function. What that means is that we can factor these. So we're going to use strategy number 4, but what we're actually doing here is factoring. If we have a secant to the 4th and a secant squared, then what they have in common is secant squared. So I'm going to factor out secant squared of beta. That leaves me here with 2 secants left, so that's secant squared. And here I've factored out everything that was there, so I have a 1 left. I can do the same thing on this side, factoring out a tangent squared. That leaves me with tangent squared beta plus 1. What that did for me is it gave me an alternate form of one of the Pythagorean identities, here and also here. So now I'm using strategy number 3. I'm going to replace this with tangent squared of beta. On this side, I'm going to replace this with secant squared beta. I'm actually using that same Pythagorean identity on both sides, just in different forms. And now, these two are really the same, even though the factors are written in a different order. So I'm just going to rewrite one of the two sides so that they look the same. I'm just going to rearrange the terms on this side. So I've got tangent squared beta times secant squared beta. And over here I have tangent squared beta times secant squared beta.